Example 4.1.2, transformer has 8 turns on the primary and 4 turns on the secondary. Determine the turns ratio of the transformer, and is this transformer a step up or step down type? So the givens in this problem are that we know the number of turns on the primary and the number of turns on the secondary. The symbol for turns on the primary of a transformer, NP, and the symbol for turns on the secondary is N sub S. So sub P for primary and S for secondary, N for signifying a count of something. N is typically used to count things, right? So that's just 8, and there were 4 turns on the primary, so 8 over 4. That's all we were given. We were asked to find a quantity called the turns ratio of the transformer and to identify the transformer type. So the solution to this is that the definition of turns ratio for a transformer is, if we have a transformer, an ideal transformer looks like this. It is the number of turns on the primary as a fraction to the number of turns on the secondary. So NP over NS is equal to 8 over 4. So we would say that is equal to 2 over 1. Often this is written as 8 to 4 or 2 to 1. Maybe a little less commonly, this could be written as 1 to 1/2 or 1 to 0.5. Any of these methods here is an appropriate way to write the turns ratio, and you'll see different nomenclatures used in different resources. So we're then, after having identified the turns ratio, we need to use the turns ratio to identify the transformer type. There are in general 3 types of transformers. There is a step up, a step down, and a isolation. And these terms refer to what is done to the voltage that is put into the primary. So step up is VP is less than VS. That means the voltage coming out of the secondary is larger than VP. In a step down type, the voltage coming out has to be smaller, so VP is larger than VS. And then in an isolation type transformer, the primary and secondary voltages are equal. So we know that the relationship VP to VS is given by the turns ratio NP to NS. And so then we can just easily see that from this example that we've got VP is equal to 2 over 1 times VS. So we see that this is a step-down style transformer because VP is larger than VS. It takes 2 VS's to equal 1 VP, so VP is larger. So the answer to this is that the transformer is a step-down type transformer, as was determined by looking at the turns ratio.